Hello everybody, welcome to another lesson by me, Miss Pythagoras. In this lesson, I will explain how to sketch a cubic function. This is the second lesson of 6 on sketching a cubic function. Remember, you can also visit my website onlinemaths.co.za and find all the chapters in the grade 11 and 12 syllabi. The link is in the comments below. And if you haven't subscribed yet, please do that now in order to automatically receive all new lessons. Back to the maths. Now in this lesson, I will specifically explain how to find x-intercepts, the y-intercept, stationary points, point of inflection, and then finally how to sketch the cubic function. There are 5 steps that we will follow. Step 1. We will look at the shape, and the shape is determined by A's sign. When A is greater than 0, you have an ascending graph. When A is negative or smaller than 0, a descending graph. The second step will be to find the x-intercept by making y 0. And there you will either take out a common factor or you will use the factor remainder theorem to factorize. Step 3 will be to find the y-intercept. There we will make x 0. Step 4, finding the turning points by finding the first derivative and equating it to 0. And the last step, the point of inflection. To find that one, you will take the second derivative and equate to 0. Let's look at some examples. Let's sketch the graph of h of x is equal to x to the 3 minus 6x squared plus 9x. First of all, the shape will be determined by a's value. A is greater than 0. You find a there in front of x to the 3. It's the coefficient of x cubed. A is greater than 0 or positive. Therefore, this is the shape of your graph. Step 2, x-intercept, make y 0. There's your equation. We make y 0. And in this one, we can factorize by taking out x as a common factor. And you're left with x squared minus 6x plus 9. The bracket you can factorize further and it becomes x minus 3, x minus 3. And then your x-intercepts will be x is equal to 0 or x is equal to 3 or x is equal to 3. And don't worry if you get x to be the same value there, because that means something. That is a specific point on your graph where your graph will not have 3 definite x-intercepts. Your graph will hop at that point. The y-intercept, make x 0. There's your equation. Everywhere where you see an x, you substitute 0, and then your y-intercept in this case is at the point 0, 0, the origin. The next thing we will calculate will be the turning point, where we find the first derivative and equate to 0. There's your function. The first derivative will be 3x squared minus 12x plus 9, and we equate to 0. Now I divided by 3 right through, and I ended with x squared minus 4x plus 3 equals to 0. You can factorize, and you end with x minus 3, x minus 1. Therefore, x is equal to 3 or x is equal to 1. Then for the corresponding y value, remember every x has an original y value. So we will substitute x is 3 and x is 1 into the original equation. There's your original equation. In x's place, we substitute 3 and we end with the point 3 and 0. Now, remember I said your two x values were the same. X is equal to 3, x is equal to 3. And now one of your turning points is also the point 3 and 0. And that is 100% what you are looking for. That is the place where the graph will hop. And then your other x value, x coordinate of your turning point was x is equal to 1. We substitute x is equal to 1 into the original equation and we end with 4. Therefore, the coordinate is the point 1 and 4. The last thing that we need to do here is we have to find the point of inflection, and therefore we will find the second derivative and equate to 0. There's the original equation. The first derivative will be 3x squared minus 12x plus 9, and the second derivative is 6x minus 12 is equal to 0. And we solve x, 6x minus 12 is 0, 6x is 12, x is equal to 2. That's the x coordinate for the point of inflection. Every x has an original y value, so into the original equation we substitute x is equal to 2 and our coordinate will be the point 2, 2. Now on the right hand side there's all the information that you need to sketch your graph. And then there is your graph. If we look at the graph there, can you see a was greater than 0, so we have an ascending graph. Let's add the arrows. The x-intercepts are at x is equal to 0, or at x is equal to 3 and x is equal to 3. Now the fact that there's two x values, can you see this is the point where the graph hops and turns. The y-intercept is at the point 0, 0, and then the turning points are there at 3, that's where your graph hop and turn, and then your other turning point is the point 1 and 4 up there. And then our point of inflection is at the point 2, 2. And remember, I taught you that the point of inflection is halfway between the two x's of the turning point, and that is the point where the concavity changes. Let's sketch the graph of f of x equals minus x cubed plus 5x squared plus 8x minus 12. We will start with the shape. A is smaller than 0 or negative, therefore it's a descending graph. X-intercept make y 0. Now in this case, it's very clear that you cannot take out x as a common factor. So now you have to revert back to finding possible factors and using the factor remainder theorem to find the factors. Remember, you look at the constant's value, the 12. Therefore, your possible factors could be plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 6, plus or minus 12. And my advice to you was, when I dealt with this chapter, I said use your calculator. So you will slot in your equation into your calculator, and everywhere where the second column, the y, is 0, that is the place where you will find your factors. And in this case, you were very lucky because the calculator gave you all three factors. And therefore, your x-intercepts will be x is minus 2, or x is 1, or x is equal to 6. The third step, y-intercept, make x 0. There's your original equation. Everywhere where you see an x, you substitute 0. Therefore, the y-intercept is the point 0 and negative 12. We still need to find the turning point of f of x. So for the turning point, it's the first derivative equals 0. There's your equation. The first derivative will be minus 3x squared plus 10x plus 8 is equal to 0. There's the equation. Now I want to factorize, so what I did was I divide it right through by a negative. Let me show you the negative there. And I ended with 3x squared minus 10x minus 8 is equal to 0. And then that one you can factorize, and the factors are 3x plus 2, x minus 4. And remember, if you can't factorize, you may use the quadratic formula to help you to find the factors. Therefore, x is equal to minus 2 over 3, or x is equal to 4. Then every x has an original y value, so now we will substitute the two x's into the original equation. There's your equation. In goes minus 2 over 3, and my advice to you is slot this in your calculator. And then you end with the corresponding y value is minus 400 over 27, but what does that mean? Rather write it as minus 14,81. And then your other x coordinate was at x is equal to 4, and then we will take 4 and substitute into the original equation, and we end with 36. So there's your two turning points. Now the last thing that we need to work out before we can sketch this graph is our point of inflection, where we will take the second derivative equal to 0. There's the original equation. The first derivative is minus 3x squared plus 10x plus 8. The second derivative will be minus 6x plus 10, and we have to equate to 0. Then we can solve x. Minus 6x plus 10 is 0, minus 6x is minus 10, and then x is 10 over 6, or 1,6. Then we can substitute x is 1,6 into the original equation. There's your original equation. In goes 1,6 or 10 over 6, it doesn't matter, with your calculator. And then your point of inflection is 1,6 and 10,59. Now we can sketch the graph. You will see the shape will be a descending graph, and then in flew the first x-intercept at -2, and then your other x-intercept is at 1, and the other one is at x is equal to 6. Then your y-intercept is at 0 and -12, and then your turning points are minus 2 over 3 and 14,81, and the other one is the point 4 and 36. And then your point of inflection is the point 1,6 and 10,59. There, it flew in. Now we can sketch this graph. I'm going to do it for you with my highlighter. So it's a descending graph. So our graph is doing that. Make sure that you cross all the points, and there is your graph. Now you know how to sketch a basic cubic function. In the next lesson, I will explain how to sketch a more complicated cubic function. Click on the video in the right-hand corner to take you straight to that lesson. This is Miss Pythagoras signing off till next time.